Hey guys, real quick, I wanted to go over how do we do the other chi-square tests besides chi-square goodness of fit in the calculator. This method works for both of the other types besides goodness of fit. So that is the chi-square test for homogeneity and the chi-square test for independence. And both of these are data fits into a table. And so that's why the two of them are a little bit different in the calculator. So for our notes over chi-squared test for independence, we were testing the independence between taco tongue and evil eyebrow. And so when you are going to use your calculator for these types of problems, the only thing that you need is the observed values. So in my calculator, I'm going to open the matrices. So I go to second matrix, which is below the math button. And here are all of the matrices. I go over to edit and I'll choose the first one, A. Now I need to create the matrix table to be the same dimensions as the table that I have. Ours has 2 rows and 2 columns, so that is 2 by 2. Oops. And it goes columns first and then rows. Okay, I know it's kind of hard to tell because this is 2 by 2, but columns first, then rows. And then we're going to start plugging in our values. So 180, 300. And if you hit enter, it moves you to the next box automatically. So you just go enter, enter, enter. And there is our matrix of the observed values. So now I'll get out of here. I'm going to go to stat. I'm going to go over to tests. And then I'm going to go up to the chi-squared test, which is letter C. Hit enter. I'm put the observed in matrix A, and then my calculator is going to give me the expected values in matrix B. So it will calculate it for me. I go down to calculate, hit enter, and there is the chi-square test for independence. We have our test statistic, which is 18.75. And then we have our p-value. Notice the p-value is not 1.49. It is 1.49 e negative 5. And so really that's saying move the decimal place to the left 5 places. And our p-value is actually 0.0000149 or 15. It would be fine as well. So in your calculator, that's how you do that. But then we do need to know what the expected values are in order to test the large counts condition. So if I want to find the expected values matrix, I will go to stat and I go, oops, sorry, not stat. I'm going to go to the matrix menu. So second and then the button under math. And now we see that next to A and B, it has a 2 by 2. So it's letting me know that those two matrices have values in them. I'm going to go down to B and hit enter. Hit enter again, and it is going to show you the expected values matrix. So I can even fill that in on my paper in this table, the expected values for all 4 of our pieces of the table. So as you do problems like this, remember to name your procedure correctly, but everything else is basically the same as the other chi-square test, whether it be for independence, goodness of fit, or for homogeneity. Really, the only differences are the wording of our hypotheses, the name of the test, and of course the hypotheses will then change how you word your conclusion, but really that the only thing that changes about the conclusion is how you reword your hypotheses. Other than that, it's the same 3 conditions, the same specific formula, the same work, the same picture, and everything else.